Contact pressure on footing problems prepared by GIS M3 Department of Civil Engineering SNIT Adur. First problem is a footing 2.6 by 2.6 meter has to carry a vertical load of 600 kN with a moment of 100 kN along one of its axes. Determine the contact pressure if the column is placed at the center of the footing. Plan the position of the column so that the bearing pressure on the footing will be uniform. Solution. Step number 1. Determine the eccentricity of the load. Eccentricity equation equal to M by W. M in the value 100 kN, W 600. So, E equal to 0.16 meter. This should not exceed the value of L by 6. L by 6 is 0.43 meter. So, 0.167 less than 0.43 meter, which implies all pressures are positive. Step number 2. Determine the pressures. Pressure on the equation P equal to W by V square 1 plus or minus 6E by L equal to 600 by 2.6 square into 1 plus or minus 6 into 0.167 divided by 2.6. We get P max 122.95 kN per meter square and P minimum is 54.55 kN per meter square. Check the average pressure P max plus P minimum by 2. We get the value 88.75 kN per meter square. So total pressure is 88.75 into 2.6 square equal to 600 T. Step number 3. Determine the eccentricity of the load to produce uniform pressure. Place the column with eccentricity of 0.16 meter towards the lower pressure side so as to produce a moment equal and opposite to that of the column moment. The resultant pressure will be uniform. Next, question number 2. Two columns, one carrying 180 kN and the other 360 kN, are spaced 2.1 meter apart and are to be placed on the combined footing. If the site bearing capacity of the soil is 100 kN per meter square and give the layout of the footing. Figure കാണിച്ചിരിക്കുന്ന ഈ footingന്റെ layout ആണ്. Solution. Step number 1. Find the total length of the footing spacing of column equal to 2.1 meter. Allow 0.16 meter beyond center of gravity of smaller load and 0.1 meter beyond center of gravity of the larger load. So L equal to 2.1 plus 0.6 plus 0.9 equal to 3.6 meter and L by 3 is 1.2 meter. Step number 2. Find the total area required for the footing. A equal to W1 plus W2 divided by Q equal to 540 divided by 100 equal to 5.4 meter square. Step number 3. Find the position of the center of gravity of the load from the large load. Taking moment about this 360 kN. 360 plus 180 into x equal to 180 into 2.1. We get x equal to 0.7 meter from 360 kN. Step number 4. Find x2, the distance from B2. x2 is x plus 0.9. x2 equal to 1.6 meter. Step number 5. Find B1 and B2. B1 plus B2 equal to 2a by L equal to 3 meter. x2 equal to 1.6 meter equal to 2b1 plus b2 by b1 plus b2 into 1.2, where x2 is center of gravity from b2. Solving this equation, we get b2 equal to 2b1. From the equation 1 above, we get b1 equal to 1 meter and b2 equal to 2 meter. Finally, step number 6, find the final dimension of combined footing. A trapezoidal footing, B1 is 1 meter, B2 is 2 meter and L is 3.6 meter. The center of gravity of the load and the area of coincidence to give uniform pressure.